Friends, this video is about introduction to theory of relativity and general theory of relativity. Theory of relativity means special theory of relativity and general theory of relativity. Now this video will be an introduction towards these two topics. The videos which I will send at later stage will consist of actual concepts, formulae, derivations, applications, all those things will follow. Why this concept is introduced in BSc syllabus? It is in compulsory paper for final year students of BSc of Mysore University. Special theory of relativity and general theory of relativity both were proposed by Albert Einstein and special theory of relativity was the fourth scientific paper published by Albert Einstein in 1905 at the age of 26 years. Albert Einstein was a German scientist. In 1905, he published 5 papers. First paper was about explanation of photoelectric effect based on quantum nature of light, proposed by Max Planck. Quantum nature of light was proposed by Max Planck and nicely adopted by Albert Einstein to explain the phenomenon of photoelectric effect. Photoelectric effect in the laboratory was discovered by Hertz in 1885. So photoelectric effect did not discover by Einstein. It was discovered by somebody else. Theory was proposed by Max Planck, and this theory and the experiment nicely explained by Albert Einstein using the photoelectric equation that is known as energy balance equation. And that equation we have all studied in our PUC. That equation is H nu is equal to H nu naught plus kinetic energy. This kinetic energy was of mv square, nu naught threshold frequency, nu is incident frequency of the light on photoelectric material, h was Planck's constant, and this was the equation given by Albert Einstein, and that paper was the very first paper written in 1905. In 1905, he wrote 5 papers starting from April to September. In the month of April, he got this. Now, for this paper, for this explanation, he gets Nobel Prize in 1921. Next, second paper given by Albert Einstein was connected to calculation of Avogadro number. And finding the mass of a molecule by studying the motion of molecules in a solution. In fact, this paper was his PhD thesis. He gets doctorate because of this paper. And third paper was connected to Brownian motion. Of particles. Random motion of particles. And this is connected to kinetic theory of gases, heat, and lot of theoretical equations, mathematics was developed in this paper. That mathematics, random motion of a particle in a medium or in an atmosphere, mathematics connected to that, and at a later stage, those equations, those mathematics were utilized by financial analysis experts to know movement of a stock price. So even this paper, though done for a science topic, was utilized by the financial experts all over the world. So that is the importance of this paper. Then came fourth paper, special theory of relativity. Now this is there in our syllabus. We will be talking in details about this special theory of relativity, defining and explaining each term in this word, in this phrase. What is special? What is theory of relativity? You should understand. Then came the fifth paper. Fifth paper was an application of special theory of relativity, and he gets the equation E is equal to mc square. And this is the famous equation everybody knows. This equation gives the relation between energy and mass of a particle or matter mass, and c is the velocity of light. So these 5 papers, this is also in the syllabus. We will be discussing this, how it is derived, all those things we will be discussing in another video. These 5 papers are known as seminal papers in the history of science, in the history of modern science, because these 5 papers developed in 1905 and the whole 20th century dominated by these papers, because further concepts in science, modern science, like development of atom bomb, hydrogen bomb, and eventually they were utilized in rather badly on Hiroshima and Nagasaki, 2 cities of Japan during the World War II, destructive purposes, which even Albert Einstein had not dreamt of. He thought for only useful purposes of his theory of E is equal to mc square, but it was used for the destructive purpose. And later on, many things connected to these 5 papers, most important them were development of lasers. You know, many uses are there lasers, about the lasers. And lasers were used in making the computer chips, microcomputer chips, and very fast computers were developed in 1980s, 1990s. And now the latest gadget is what you are using in your hand now, that is the cell phone, right? The technology behind it, right? The science behind it had the roots in these 5 papers. That's why Albert Einstein is known as scientist of the century. He did many other research papers well before this also, but these are known as very famous papers of 1905. And later on, in 1915, he develops a paper known as GTR, General Theory of Relativity. This is there in our syllabus. General Theory of Relativity. This is general theory and this is special theory. Now, what is the difference of that? I will be coming to that at later stage. Before we get into the concepts of special theory of relativity, we should know few definitions, few terminologies used in special theory of relativity. Now, I will be explaining few concepts connected to that. The first one is, what is velocity? What is velocity? What is relative velocity? So the velocity, as you know, it is given by distance by time. Distance by time. Now, for example, there is one vehicle moving in this direction with 100 kilometers per hour. This is the velocity. So this means it is moving in 1 hour 100 kilometers. Let us say there is another vehicle it is moving in this direction with 40 kilometers per hour. 40 kilometers per hour. Then I will say, let us say this is A vehicle, this is B vehicle. Now relative velocity of A with respect to B is equal to 100 minus 40. That is 60 kilometers. This is relative velocity. So, velocity of this with respect to this. Velocity of this with respect to this. If I write velocity of B with respect to A, this is relative velocity of B with respect to A, I have to write 40 minus 100. That is minus 60 kilometers per hour. Now, direction of this vehicle and direction of this vehicle, this is also in this direction. This is opposite. This direction, this direction. Then I will say VAV will be equal to 100 plus 40. 140 kilometers. This is the relative velocity of A with respect to B. Similar relative velocity of B with respect to A will also be same 100 kilometers per hour. Now, this is the relative velocity. Now, if I say, now frame of reference. If I measure the velocity of this, how do I measure? I will take frame of reference like this: x-axis, y-axis, z-axis. This is the origin. And this frame of reference, so this is on the earth. This is on the earth. Now, here we assume earth is at rest. When you are measuring velocity of one particular vehicle, I will take this reference point, reference frame will be on the earth. Earth is taken at rest. So earth velocity is 0. This velocity is 100. Then if I say, what is the velocity of A with respect to this, means 100 minus 0, that is 100. That means, even when I say velocity of a particular bus means, it is also relative to something else. In this case, it is earth. If a car is moving on the earth, if I say its velocity is 20 kilometers per hour, it means it is moving on the earth relative to the rest position of the earth. Earth's velocity is 0, and with respect to that, it is 20 kilometers per hour. This is as long as things moving on the earth are concerned. This is known as frame of reference. Now, we'll be talking about other frames of references. Inertial frame of reference. Inertial frame of reference, here as long as you don't consider the movement of the earth around the sun with certain velocity or with certain acceleration, if you don't consider that, if you neglect that part, then earth can be considered as inertial frame of reference. This is one example. Second example, if there is a train moving with constant velocity, for example, train starts from Mysore, it keeps moving in the direction of Bangalore with a constant velocity. For example, velocity is always 80 kilometers per hour. Most idealistic condition. Actually, it will not constant, it cannot keep 80 kilometers per hour constant from here to Bangalore. It keeps changing. But if there is a train moving with constant velocity, in the train, if you are sitting there, your frame of reference will be inertial frame of reference. If there are two boys playing in that train, if you want to measure certain things connected to them like velocity or something else, your frame of reference will be inertial frame of reference because you are sitting in a train which is moving with constant velocity. Suppose a train is moving with acceleration. In fact, this is the actual thing. From Mysore to Bangalore, train first it starts with some 10 kilometers per hour, then it will pick up 20, 30, 40, 50, like that. Its velocity is changing. That means it is accelerated. Now, if you are sitting in the train and if you have got a reference frame, then that is known as non-inertial frame of reference, because train is getting accelerated. So your thing is non-inertial frame of reference, that is also known as accelerated frame of reference. That is the second example. Third example of accelerated frame of reference is anything which is moving in a circular path. For example, I have something like this. There is a pendulum which is set into circular path. It's moving like this with a constant velocity. It's moving with constant velocity, but it is in a circular path. At every point in its path of the circle, its velocity keeps changing because direction changes. So it becomes a vector quantity, the velocity changes, and hence it has got acceleration. So on this, if you have got reference frame, on that circular path, it will be accelerated frame of reference. So we'll be talking about this. We'll be using these concepts in my next video, where I'll be talking about Michelson-Morley experiment and its negative results, and further how the special theory of relativity can be introduced at that stage. I'll be talking about that. Thank you.